Hi, this is Mrs. Basin, and in this screencast we're going to talk about using gas stoichiometry at STP. So we've talked about using gas stoichiometry so far, but under certain conditions there is a certain conversion you can use that will make these stoichiometry problems a little bit easier. When you are under the conditions of standard temperature and pressure, 1 mole of a gas is exactly 22.4 liters. So what that means is if the temperature is exactly 273 and the pressure is exactly 1 atm, which we call those conditions again STP, or standard temperature and pressure, you can use the conversion 1 mole equals 22.4 liters. So if those conditions apply, every gas, 1 mole of any gas, no matter what it is equal to 22.4 liters. So if you're looking for the volume of a gas, and you're at STP, you can do the stoichiometry, and you can do this problem all in one step, instead of having to do part of it in stoichiometry, and then the other part using the ideal gas law, or PV-nRT. And again, you can only use this value if it says the conditions are standard temperature and pressure. So let's look at a quick example here. So this one says we have quicklime, which is calcium oxide, is made by heating calcium carbonate to produce calcium oxide and carbon dioxide gas. So this is a calcium carbonate decomposition reaction. So we want to know what is the volume of CO2 produced at STP from the decomposition of 152 grams of calcium carbonate. So again, the way we will know that this is one of these types of problems is it's going to somehow in there give you the description of the chemical reaction. And then this particular one, it says we're at STP. So if we're at STP, then we know that we can do this all in a single stoichiometry problem, because at STP, 1 mole of gas equals 22.4 liters. Okay, so we're going to start this out the same way. Before we can do anything, we have to have a balanced equation. So calcium carbonate is decomposing, so CaCO3 decomposes to give us CaO and CO2. Okay, so that's our balanced equation. We're going to start with our amount of calcium carbonate. So we're starting with calcium carbonate, but what we want to find out is we want to know how many liters, or what is the volume of CO2 produced. So I'm going to start with my 152 grams of calcium carbonate. I'm going to change it to moles using molar mass. So 1 mole CaCO3 equals 100.10 grams, and that's just the molar mass. I just added all the elements up. Now I can do my mole ratio between calcium carbonate and carbon dioxide. It's 1 to 1. So 1 mole calcium carbonate to 1 mole CO2. And then my last step, I can use my molar volume conversion. Now, if this was not at standard temperature and pressure, I would have to stop here, and then I would have to take it into a PV-nRT problem. But because we are at STP, I can do this, like I said, in one step. So 1 mole of gas equals 22.4 liters of gas. So I go through and do my whole calculation, and I end up with 34.0 liters of CO2 gas produced. And once again, this is only, you can only use this conversion if the conditions are standard temperature and pressure. And those conditions, again, standard temperature and pressure means that the temperature is 0 degrees Celsius or 273 Kelvin, and the pressure is exactly 1 atm.